Welcome. In this video, we're going to do a really basic introduction to the concept of linear momentum. The reason why we're going to do this is that it's important that we have at least a really basic understanding of what linear momentum is before we look at Newton's second law. The idea of momentum, this quantity known as momentum, is actually a fundamental concept in Newtonian mechanics. Like I said, in this video, we're just going to take a really quick look at momentum. But a little bit later on in the course, we're going to look at momentum in much more detail and look at its applications and implications. So the formula for momentum, or what momentum is really pretty straightforward. The linear momentum of an object is equal to its mass times its velocity. So in this course, I'm going to use the capital letter G to stand for linear momentum. So this is momentum of things moving in a straight line. The textbook uses the letter P for linear momentum, which is sometimes used as well. Even though the formula for momentum is pretty simple, it actually combines a couple of really fundamental concepts within Newtonian mechanics. So linear momentum is the mass times the velocity, but conceptually what that means is the velocity is a measure of the state of motion of an object, and we've kind of talked about that already when we were talking about Newton's first law. And mass is a measure of the resistance to the change in that state of motion. So what momentum is a combination of these two measures. So if you know an object's momentum, what that is an idea of both what the object is currently doing, or the object's current state of motion, and how hard it is to actually change that state of motion. So those two kind of concepts are combined together in momentum. And so momentum is actually, you have to think about it as the combination of those things. So it's not just the mass or the inertia, and not just the state of motion or the velocity, but it's the combination of those two things that come up with this quantity known as momentum. And so, for example, here, if we've got a 7 kilogram bowling ball and it's moving at a velocity of 6 meters per second, then its linear momentum is simply its mass times its velocity. So 7 kilograms times 6 meters per second, and you get 42 units of momentum. So that bowling ball, if it was moving like that, would have 42 units of momentum. And that momentum is a combination of what the bowling ball is doing, so moving at 6 meters per second, plus how hard it is to change that state of motion, or the inertia, which is the 7 kilograms. So you combine those two things together, you get 42 units of inertia. But you could also look at a 2 kilogram discus, and a fairly decent release would be about 21 meters per second. So if you had a 2 kilogram discus flying at about 21 meters per second, and you look at the momentum of that discus, you see the momentum is the mass times velocity, so 2 kilograms times 21 meters per second, and that would also be 42 units of momentum. So the 2 kilogram discus and the 7 kilogram bowling ball can both have the same amount of momentum depending on their current state of motion. Or something moving at 6 meters per second can have the same amount of momentum as something moving 21 meters per second depending on the amount of inertia. So momentum is the combination of inertia and state of motion.